Hey,
Hello.
1.10 today with Witterson. You should open up your books to page 89.
We're going to compare and order real numbers, and we're going to talk about the real number system. So
Perfect.
let us get going. All right, so first example, real world link. Major League Baseball has rules for the dimensions of the baseball diamond, and you can see a model of the baseball diamond at the right. So on the model, the distance from the pitching mound to home plate is 1.3 inches. So from here to here, or here to here. Is 1.3 a rational number? We'll go back in time.
Okay.
Rational numbers, what's the definition of rational numbers?
Repeating or terminating decimals.
Or can be written as anything that can be written
Yeah.
as a fraction. So this, can I write this as a fraction? Yes.
Yes.
So yes, it is. It can be written as, wow, that's terrible writing. It can be written as 13 over 10.
You got it.
Or 1 3/10.
Yep.
Anything like that.
There you go.
Okay, now on the model, the distance from first base to second base is 2 inches. Boom. Is 2 a rational number? Well,
Yes, it can be written as a fraction.
It could be 2 over 1.
Yep.
Okay, so let's keep looking. The distance from home plate to second base is square root of 8 inches. Using a calculator, find the square root of 8. Does it appear to terminate or repeat? So, I don't think
I don't know what that is off the top of my head.
I don't either, but I don't
Right.
think this calculator doesn't do square root. So,
Well, I have the answer for us.
okay, so the square root of 8 is
2.828427125.
okay. Now, does that appear to terminate or repeat?
Well, it doesn't look like it's repeating.
No repeat.
Okay. There's not a ... at the end, so that's telling me that it does terminate. So it appears to terminate.
Now
yes.
look what this says. Okay. Appears to terminate. Now, the next question is asking us to square it and see if it actually is a term. So we're going to determine if it terminates. Wow.
Determine if it terminates.
So on your calculator, take this answer that we just got and multiply it by itself. Do not use the x squared button. So should I do that?
Yeah.
Okay. So I'm going to have
2.828
yeah,
427.125
times
Oh geez.
2.828
427.125
125. And if it does terminate, then I should get 8, right?
Right.
Oh, nope.
You kind of have 8.
I kind of have 8, but I got more than 8.
Right.
So, is the answer 8? No. So, based on this, can we classify the square root of 8 as a rational number? No.
No.
Why?
Well, because it didn't come out to be 8 exactly.
It is not a terminating decimal, right?
Yep.
Not a terminating
Or repeating.
decimal.
Yep.
Not repeating. I'm so sorry about my handwriting on this, guys. I'm writing kind of weird. Maybe I'll move my hand. All right, so let's look into this deeper. Key concept. We are talking about real numbers, okay? So we've got rational numbers and irrational numbers. We talked about this earlier.
Yeah.
Rational numbers can be expressed as a fraction. Irrationals cannot. So terminating, repeating.
Yep.
Non-terminating, non-repeating. So the thing you need to look for the most is this right here, that ... And in here, if you ever see anything that repeats.
Right.
Like if it went 1 4 1 4 1 4 or whatever.
Right.
Okay. So let's look at some examples down below. The numbers that are not rational are called irrational. We talked about that. And there's a whole bunch of subsets of the real number system.
Right.
All right. So here's what I want you to write. Rock it with numbers. Write that down. This stands for each one of the subsets. So R stands for
Rational.
rational. Within rational numbers, R next it stands for integers. Next after that are whole numbers. And lastly,
Natural.
natural. So let's talk about each one of these subsets. Rational numbers are obviously anything that terminates or repeats. Integers are whole numbers and their negative opposites.
Right.
Okay. So -1, -2, -3, 1, 2, 3. Those numbers on a nice, good looking number line.
Right.
Whole numbers you should remember from kindergarten.
Yeah.
No, 0,
Start
1,
with
2,
0.
0, 1, 2, 3, 4, 5. And the natural numbers are numbers that you naturally
Naturally
can
speak.
count,
Mhm.
or you start naturally counting with 1, 2, 3, 4. Okay, so again, rocket with numbers is the way to remember that. Oh, where's my deal? Here
Up
it is.
top.
Up top. So we are going to compare and order these numbers. So the first thing we're going to do, it says fill each bubble with greater than, less than, or equal to make it true. So the first thing we're going to do is we're going to change all of these things to decimals to compare them.
Right, so they're all the same.
Okay?
Mm-hmm.
And so they're going to be in that same format. So the square root of 7 is this, 2.64, blah, 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 blah. Notice how it it has the dot, dot, dots. We know that that's an irrational
Right,
number.
doesn't stop.
And then we're going to change this to a decimal by doing 2 divided by 3, and we get this.
So you leave the whole number as 2, and then 2/3 becomes the decimal behind that.
And here's
so
that
2
again.
Point.
So we're comparing 2.64 to 2.66. So clearly 2.66 is bigger.
Mm-hmm.
So I'm going to do this,
Perfect.
right?
Then there's a number line to show that.
And
You don't have to do that, but that's where it is. That's what we're just showing you.
Yeah.
It's a connection.
So number 5, we're going to compare 15.7% to the square root of 0.2. Again, change your percent to a decimal. So move that decimal 2 places to the left, like they've done here, and you get 0.157.
Mm-hmm.
The square root of 0.02 is 0.141.
So again, you just plug that in your calculator and you have it.
Yep, and since
So which one's bigger?
obviously this one,
Mm-hmm.
easy peasy.
There you go.
Okay,
Moving on.
this thing keeps moving on me. Okay, now we're gonna,
You're moving.
I'm
it.
moving it, I know.
Oh.
All right, we're gonna put all of these in order, least to greatest. Again, change them to a decimal, underline this or highlight, write each number as a decimal, then put them in order. So you can see here, everything has been written in decimal format, and we've ordered it from greatest to least. So, or no, least to greatest or greatest to least? Least to greatest.
Yep. So you will be expected to write those out in the decimal, okay?
Mhm.
you're
So
gonna have
this
to do
is
that first
showing your
step.
work. And then when you put them in order, notice how it's in the original form. So I'm not writing the decimals out, I'm writing out the original form.
Yep.
Okay? Moved it over here. All right, now you're gonna practice these on your own. You do not need to worry about the number line stuff, and I've skip it.
Yep.
So change to decimal and order. Go ahead and pause now.
All right, how do we do?
Okay, this first one, you should have less than. Less than looks like an L.
Mhm.
That's the way you know it's not the alligator eating the bigger number. It looks like an L. This one, you should have greater than. And the last one, guys, is equal to. And then our last one, order the set from least to greatest. The smallest is
Negative square root of 60.
negative square root of 60.
Negative 7 7/10. Negative 66 over 9. And
then
negative
negative
7.
7. All right. How'd you do? Hope you did good. Dang it, I keep looking the wrong place. All right, here's your guided practice.
Notice what is canceled out at the bottom. So yes, you're doing part of number 7,
You still have to do this part.
okay? You just do not have to verify your answer using a graph. But you're more than welcome to use that number line and plot them on there if that helps you, but you're not required.
Okay, now let me point out this. Name all sets of numbers. That means which sets, is it a whole number? Is it an integer? Is it an irrational number?
Right.
All of them.
So think about rock it with numbers. If it is a in, okay, if it's a number, then that means it has to be the W, the I, and the R, okay?
It's all of these. Okay?
I would probably write that down on your paper.
I would
now.
too. Okay, gang, we will see you.
On the flip side.
Bye-bye.